738 notes, powers, radicals, and rational expressions. A lot of definitions and terms today. I don't think today is going to be too difficult, but just some new terminology, some new buttons that we're going to find on our calculator. So if you don't have your scientific calculator with you, you're going to want to grab that because we're going to learn some different keystrokes, a lot of computer calculating. A power we defined earlier. A power is when it's repeat multiplication. So I am going to multiply x by itself n number of times, and then y would be my answer. Okay, and so really the definition of a power is that it's repeat multiplication. We're going to multiply base x by itself n number of times to get y. Well, every power has an inverse. So we talk about inverse operations. Addition and subtraction are inverses. They undo each other. Okay, they get us back to zero. Multiplication and division undo each other. They are inverse operations. And so radicals are the inverses of powers. And so when I show you the radical notation, that little square root sign, but it applies to more than just square roots. It's any root. It's taking a number back to its base. And so if you see that the answer of a power, the y value, is underneath that symbol, that's called the radical sign. The exponent that you raised, the repeat multiplication, is the little number here called the index. And it tells you, it helps ask the question. And then your answer here is getting back to that base. Okay, so a best way to describe it is what I have written down here. The inverse of a power, radicals ask, what number x was multiplied n amount of times to get y? So I know when we talk about x's and n's and y's, it's a little confusing. So let's kind of use these three examples here. So this 5 squared, right? Remember 5 squared, the little 2 means squared. It means multiply by 5 by itself twice, and you get 25. Come across the page, and you can see that this little symbol is asking, what number did you multiply by itself twice to get 25? Now this is called a square root. There's no 2 there. It's understood. So only for square roots, because it's the most common root that we take, we don't have a number there. Okay, the index isn't shown. And so they're asking, what number did you multiply by itself twice to get 5? And the answer then is 5. Okay, so you take the 25 answer here, and that goes underneath the radical sign, and we're getting back to that 5. If you look at the next example, okay, 6 to the third power, that's 6 cubed. That's 5 times, or not 5. That means repeat multiplication of 6 3 times. 6 times 6 times 6 ends up being 216. Now, to do that in your calculator, you could put 6 times 6 times 6. But what I want you to do right now is look for the calculator key that actually has either a caret button, it's like an upside down V, or maybe like a x to the y power button. Okay, both of those will work. You may even have an x cubed button on your calculator. You might have an x squared button on your calculator. So everybody try that and try to get your calculator to tell you 216. If you have these caret buttons, you hit 6, you hit that caret, and then you got to tell the calculator what power you want to raise it to. It's like pushing the 6 up, that pointing up, saying I'm raising it to some power, then you got to tell the calculator what power. Same thing for squared. We could have written it as 5 caret 2, but there's also probably an x squared button that you could push. So 5x squared gives you 25. Now, to undo that, we use the cube root. So this was square root. It takes us back to the root when you multiply a number by itself. A cube root undoes the cube of a number. And then anything bigger than that, we just refer to it as the nth root, because it can go on forever and ever and ever. So to take the cube root of 216, what we are asking here is what number did we multiply by itself 3 times to get 216? And the answer is 6. So to get our calculator to give us that answer, again, look at your calculator. everybody probably had the square root button, no problem. So whatever number, like if you have this caret button, you're going to be looking for a root button, something like that. Maybe the X's and Y's are in different spots. Maybe there's rectangles. I'll kind of help you guys out tomorrow. Okay, and so that would probably be above this. And so that's a second feature. So what you have to hit is, in order to do that, and it depends on your calculator, what kind of calculator you have, the order in which you have to hit these buttons. But most of them will tell you to do 3, second button, and then the caret, which will be the problem above it. And so you're telling it, I want to take the cube root of 216. That might be one way you have to do it. Other calculators, you may have to type in 216 first, then hit the second button, and then hit the caret, and then tell it 3. So if you notice, it goes in reverse order. Those are like the Yoda calculators. So we'll clean that up if you're not getting the 6. You want it to give you 6 in the end. 2 to the 5th, use your caret button to do that, or you can expand it out. It means the same thing as 2 multiplied by itself 5 times, which gives you 32. And then the 5th root of 32 is undoing that. It wants us to get back to 2. It's asking, what number did you multiply by itself 5 times to get 32? And the answer is 2. Okay? So a lot of button pushing and getting familiar with our calculators for this assignment. Now, that should be mostly review for you, those buttons. We're going to talk about rational exponents. The term rational means numbers that you can write as fractions. So if you're going to have a rational exponent, that means these exponents, these little powers, can be fractions. So it's a little odd. We won't do a ton with them. We will do more with it in Algebra 2. But we're going to learn just what they mean so we're not freaking out when we see them in Algebra 2. Expressions written with rational exponents can also be written as radicals. And radicals can be written as rational exponents. So this great big example down below is showing you how you rewrite it in different terms. Okay, think of it as when you first learned how to write 5 times 5 as 5 squared. It was weird at first, but once you got the hang of it, it was just something simple. So if you have a number, a base, b, raised to the mnth power, okay, a fraction power, how you convert that to a radical is you place that b value underneath the radical, okay, and then we got to figure out where these m's and n's go. The denominator is the index. That turns into the index. That's the root that you're taking. And then the numerator turns into an exponent. I'll show you with numbers. Now, we could do the same thing, but we could put that n value, we can raise the base to the mth power, or we can raise the whole thing to the mth power. It really doesn't matter where you put the m, inside the radical or out, applying it to the whole thing. Sometimes it makes more sense to put it one place or the other. Okay? So it's going to take some time. You're going to have to memorize where these numbers go. So let's go ahead and give it a try. So the first 3, we're taking powers written with rational exponents and rewriting them as radicals. So for the first one, when I have 81 to the 1/2 power, what that really converts to is the 81 goes inside the radical, and I'm taking the square root of it. So I could put a 2 here and the 1 here if I wanted to, but 81 to the first is kind of understood. You really don't need to put the 1 there. And the squared, we usually don't put that there. So the best way to say that is that anytime you have any number raised to the 1/2 power, it turns into the square root of 81. And I think all of you guys know that the square root of 81 is 9. You could use your calculator and you could type the square root of 81 and you would get 9. And then if you use your calculator and raise 81 to the 1/2 power, you would also get 9. All right, number 2, the only thing being raised to the 1/4 power is the m value. So 12 is being multiplied by m to the 1/4. So this is the only thing that we're going to convert. So 12 can stay on the outside and it can multiply m to the 1/4 as a radical. The m goes inside. It's being raised to the first power, and it's the fourth root of m. So I know if you feel better with putting the 1 out in front of or after that m, that's fine. There's your 1/4. But the 12 was being raised to the first power, so it doesn't get applied there. Number 3, x is going to go inside the radical sign. It's the fifth root of x to the fourth. There's your 4/5. Or if you wanted to, you could write it as the fifth root of x and then take it to the fourth power. The 4 can go inside or it can go to the whole thing. Okay, so it's just going to get some time and to get used to that conversion. Let's try it the other way now. So if I have the square root of 38, 38 is being raised to the first power. And when there's no number here for the index, it's assumed that it's 2. So to rewrite that with rational exponents, it becomes 38 to the 1/2 power. For number 5, I've got an exponent of 3 and my index of 4. That becomes x to the 3/4 power. And number 6, it just shows you that the 2 is on the outside. The 2 on the outside is the same thing as if it was in the inside. And so we get m to the 2/3 power. So part of your homework or the classroom work will just be simply converting back and forth. If they give you the radical, you're going to write it with the exponent. If they give you the rational exponent, you're going to write it as a radical. The other part, sorry. The other part is just practicing with your calculator. I want you to get these keystrokes down. I want you to know how to put this in using your power button, and then I want you to be able to put it in using your radical button. So we'll kind of practice that when you guys come in. Again, it might be this for the power, and then second, that gives you the button above it. And so you'll just have to work with that. So when you type these in, let's just see how you guys can do, and we can go over calculator issues tomorrow because there's so many different versions. But if I type this strictly into my calculator, I would write 1331 caret, and then to put a fraction in there, you can use your fraction button, or you can just say 1 divided by 3. I would say that I'm raising it to the 1 divided by 3 power. I would use parentheses around that so that your calculator knows that you want to raise it to the 1/3 power, not 1 power, and then divide by 3. It's really important, those parentheses. So when I type that into my calculator, you should get 11. Turns out to a nice number. Okay, so if we do it the other way and convert it and say, I don't like that format, I want to take the cube root of 1331, because that's what that is, and you use your calculator that way, so I would hit 3 second caret 1331, and that tells my calculator I want to take the cube root of 1331. You should also get 11. So just try both ways, and on your homework you can figure out which way you want to do the calculations. Okay, so for number 2, if I type that into my calculator using the exponent, 2,401 raised to the 1/4 power, you should get 7 as your answer. If you want to convert it to a radical, it's really asking for the 4th root of 2401. And when you type into your calculator that way, you should also get 7. So just practice the calculator strokes. It's so important that you communicate with your calculator the right way. 32 to the 2/5. When you type that into your calculator, 32 to the 2/5. You could take 2/5 and change it to a decimal, which is 0.4. So you could raise it to a 0.4 power. You should get 4. If you're going to type it in as a radical, that would be the radical 5th root of 32. I'd figure that out and then raise it to the 2nd power. So after you find the 5th root of 32, you could put the squared on the outside, or you could take the 5th root of 32 squared. But in the end, you should get 4 either way. Okay? Number 4, I just want to show you how you can do this by hand. It's a little smaller numbers. Okay, I don't need my calculator at all. If I have the cube root of 8 squared, that is the cube root of 64. And I know that the cube root of 64 is just 4 times 4 times 4. But if you don't like that, go ahead and use your calculator. You should get 4 for number 4. And the fourth root of 16 cubed. Well, the fourth root of 16, the number that you multiply by itself 4 times to get 16 is 2. And when you get 2 and you cube it, you should get 8. So you don't need to show that work. I'm just showing you that they do simplify if you just do the powers by yourself. And you get the 2 cubed is equal to 8. Okay, that's pretty much all that's going to happen in this section, just introducing you to that new language. So in this section, I want you to give me an example of a power of some number and then its inverse radical. So I want you to do some number raised to the power, give me the answer, and then show me how you would set that up as a radical to do the inverse. And the practice problem, I want you to rewrite that. So I'm giving you the 5th root of 3 to the 4th power. I just want you to convert it to the rational exponents.